Imagine, if you will, a time 4.5 billion years ago. The Earth, a young, fiery planet, is just beginning to cool and solidify. In the vast cosmos, a new player entered the stage. Our Earth, a sphere of molten rock and metal, spinning wildly in the void. Its surface, an unfathomable 5,700 degrees Celsius, was a picture of chaos and violence. Yet within this tumultuous environment lay the seeds of something truly extraordinary: life. But how did we go from a seething, incandescent globe to a vibrant, life-sustaining planet? Well, it took Earth nearly 1 billion years to cool down to a temperature where life, as we know it, could potentially exist. This is an unimaginable length of time, a span that outstrips our human comprehension. But in the grand cosmic calendar, it's but a blink of an eye. Yet, even as the planet cooled, the question remained: how did life actually begin? This is where theories come into play. One of the most enduring is the primordial soup theory. This posits that life arose from a rich organic broth that filled the Earth's oceans. Picture, if you will, vast oceans teeming with organic compounds, a veritable smorgasbord of life's raw ingredients. In this primordial soup, through a process we're still trying to fully understand, the first spark of life ignited. Perhaps it was a bolt of lightning that provided the necessary energy. Or perhaps it was the bombardment of cosmic rays. We may never know for certain. What we do know is that this was a critical juncture in our planet's history. The first stirrings of life were about to manifest, a process that would eventually lead to us, to humanity. As the Earth cooled, the stage was set for life to make its first tentative steps. And so our journey into the past begins, as we delve deeper into the fascinating history of ancient life on Earth. Around 3.5 billion years ago, Earth witnessed the birth of its first life forms. Imagine, if you can, a world vastly different from the one we inhabit today. A world devoid of the bustling life we're so accustomed to. It was in this primal setting that the first whisper of life emerged. These pioneers of life were humble, single-celled organisms, microscopic in size, yet monumental in their significance. They were called prokaryotes, devoid of a nucleus, yet bursting with potential. The blueprint of these early life forms was strikingly simple, composed predominantly of water, along with organic compounds such as proteins, carbohydrates, and lipids. Their environment was equally stark, an inhospitable landscape marked by extreme temperatures, high radiation, and a lack of oxygen. Yet, against all odds, they thrived. These tiny life forms were more than just survivors. They were innovators, continually adapting and evolving to the conditions around them. One of the most significant leaps in their evolution was the development of a process we're all familiar with: photosynthesis. This critical development occurred roughly 2.5 billion years ago, forever altering the course of life on Earth. Photosynthesis allowed these organisms to harness the energy from the sun and convert it into chemical energy, releasing oxygen as a byproduct. This was a game changer. It marked the beginning of the oxygen revolution, dramatically changing Earth's atmosphere and setting the stage for more complex life forms to evolve. These simple organisms, these pioneers of life, held within them the seeds of all life to come. From the towering redwoods to the soaring eagles, from the majestic whales to us humans, we all owe our existence to these humble, single-celled organisms. They were the first to brave the unknown, to venture into the uncharted territory of life. They were the architects of life as we know it. These simple organisms paved the way for more complex life forms to evolve. They set the stage for the grand spectacle of life, a spectacle that continues to unfold even today, 3.5 billion years later. Fast forward to around 541 million years ago, a period known as the Cambrian explosion. This remarkable period in Earth's history was nothing short of a biological Big Bang. Imagine, within a blink of an eye in geological time, say 10 to 25 million years, life on our planet dramatically diversified. The Cambrian explosion was like a grand debutante ball of evolution, where virtually all major groups of animals first appeared. From a planet dominated by simple, single-celled organisms, we suddenly had a world teeming with a variety of complex, multicellular creatures. Now, you might wonder, what sparked this explosion of life? It's a question that has puzzled scientists for years. Some suggest it was due to a rise in atmospheric oxygen, which provided the energy needed for the development of larger and more complex organisms. Others propose it was triggered by the evolution of vision, which led to an arms race among species, accelerating their evolution. But what's truly staggering is the sheer number of new species that appeared during this period. It's estimated that the number of animal phyla, that's a high-level category in taxonomy, increased from a mere 3 before the Cambrian explosion to an astounding 35 during this period. That's an increase of over 1100%. The Cambrian explosion also saw the emergence of the first predators. Before this, life was pretty peaceful. But with the arrival of these predators, the food chain was established, setting the stage for the survival of the fittest. So, to sum it up, the Cambrian explosion was a period of rapid evolutionary development. It was like a switch was flipped, and life on Earth went from slow and simple to fast and complex. It was a crucial turning point that laid the foundations for the diverse ecosystems we see today. The Cambrian explosion set the stage for the evolution of complex ecosystems. The Mesozoic era, from 252 to 66 million years ago, was the age of dinosaurs. Picture a world teeming with creatures of immense size and diversity, from the colossal Argentinosaurus, stretching up to 100 feet in length, to the diminutive Compsognathus, no larger than a modern-day turkey. Dinosaurs dominated the land, sea, and air, evolving into a dazzling array of forms in response to the changing environment and ecological pressures. Let's delve into the data. Paleontologists estimate that over 500 distinct genera of dinosaurs existed, with thousands of species spread across 3 major periods: the Triassic, Jurassic, and Cretaceous. Dinosaurs existed for a staggering 160 million years, a testament to their adaptability and resilience. Yet, despite their long reign, dinosaurs were not invulnerable to the capriciousness of the cosmos. The Cretaceous-Paleogene extinction event, approximately 66 million years ago, marked the abrupt end of the dinosaurs' dominance. The most widely accepted theory? A catastrophic asteroid impact. Supporting this is the Chicxulub crater, a vast impact site off the coast of Mexico, coinciding with the extinction timeline. The cataclysmic event would have caused a nuclear winter, blocking sunlight, disrupting photosynthesis, and leading to a deadly chain reaction across the food chain. Further evidence comes in the form of a thin layer of sediment worldwide, enriched with iridium, an element rare on Earth but abundant in asteroids. This iridium layer marks a clear line in our planet's geological record, a grim reminder of the day the Earth changed forever. Yet from this cataclysm, a new age dawned. With the dinosaurs gone, mammals, once small and nocturnal, had the opportunity to diversify and grow, eventually giving rise to a species capable of understanding and appreciating the grandeur of the dinosaurs, Homo sapiens, or as we like to call ourselves, humans. The extinction of dinosaurs led to the rise of mammals, and eventually us. About 300,000 years ago, a new species emerged on the scene, Homo sapiens. This marked a pivotal moment in the history of life on Earth. The evolution of our species, Homo sapiens, is a fascinating journey that spans hundreds of thousands of years. From our early ancestors, the Australopithecus, who roamed the African savanna around 4 million years ago, to the rise of Homo habilis and Homo erectus, each stage of human evolution has been marked by significant advancements. Over time, Homo sapiens began to spread across the Earth. The first major human migration out of Africa is believed to have occurred around 70,000 years ago, leading to the colonization of every corner of the globe. This was followed by the development of civilization, a process that began roughly 10,000 years ago with the advent of agriculture. From single-celled organisms to complex humans, the story of life on Earth is a testament to the power of evolution.